Today we are going to do lesson 2, algebraic equations and tables of values. We're going to start by looking at a table of values. We have the x value and the y, and the relationship that that table of values defines is x plus 1 is equal to y. And we know that this is true because as we go up 1 on the x, you can see that we start at 2, so 1 produces 2 on the y, and then we're going up by 1, right? 2 to 3 to 4 to 5 to 6, and we're adding that 1 each time. So we take our x value, 1, add 1 to it, and get the y, and then we can see the pattern building in the relationship. So let's use that understanding of how tables of values and equations work to create a table of values. So we have this equation y is equal to 2x plus 3. So we set up our table of values and draw a nice straight line there. We have x and y. So we choose some values for the x, usually 3, 4 or so. So let's do 0, 1, 2, 3, and 4. And then we go and say, okay, well, if x is 0, what is y? Well, 2 times 0 plus 3, oh, that gives us 3, because 2 times 0 is 0, plus 3 is 0 plus 3 is 3. We do the same thing with the 1. 2 times 1 is 2, plus 3 gives us 5. And again, we just continue to do this. 2 times 2 plus 3, we do the 2 times 2 first. That gives us 4. 4 plus 3 gives us 7. Now, we can see here that we're adding 2 every time. And so I could follow the pattern now and simply add 2. And that should complete the table of values. Now let's check it. So let's do the 2 times 3 plus 3. So we have 2 times 3, which we do first. That gives us 6. 6 plus 3 is 9. Oh, okay, good, it worked. And 2 times 4 plus 3. We have 2 times 4, which is 8, plus 3, which gives us 11. And so we can see that once we establish the pattern, we can use the pattern to continue to fill out the table of values. Let's go on to the next example. We're going to write the equation from the table of values. And so we need to look, we'll start here with this x and y. We need to first look at how these are changing. Here we're going from 3 to 5. Well, if we go from 3 to 5, we're adding 2 each, and we're adding 2, and so on. We're adding 2 each time. So what that means is when I build my equation, y is equal to some number times x, the piece that is being added each time is what we're multiplying by. And then we need to determine what's this plus or minus that comes at the end of the 2x. So is it 2x plus something or 2x minus something? So let's see what that is. And now if I take my 1 and I multiply it by 2, so 1 times the 2, well, that gives me 2, but I need 3, so I would need to add 1 to get 3. So I'm going to make the conjecture that I need to add 1 to each time after I multiply by the 2. So let's test the 2. 2, so I have 2 times 2, which gives me 4. 4 plus the 1 gives me 5, and so it works. Let's do test one more. 2 times 5, so I've got the 5 here. 2 times 5 plus 1. 2 times 5 is 10, plus 1 gives me 11, and so that is the equation that would define that set of values. Let's look at our next example here. I'm looking at what I'm doing here, and I'm subtracting 1, subtracting 1, subtracting 1 every time. So that tells me that when I set up my equation, y is equal to something times x, that's going to be -1. And then we need to decide if we're adding or subtracting that some value. So if I take 1 from there and I multiply -1 to it, so I take this first 1, multiply -1, that gives me -1, and I need that to become 8, right? Because here I go from 1 to 8. And so I have to ask myself, well, if I have -1 and I want to get to 8, how much do I have to add or subtract to it? Well, I need 8, and I need more than 8 because I'm down 1, so it's going to be +9. So I have -1x plus 9. Or this can be written as y is equal to -x plus 9. And in your textbook, it's written differently. It's x plus y is equal to 9. I tend to keep mine in the y equals, and in the future you'll understand why we use the y equals instead. So your textbook writes things a little bit differently sometimes. Okay, I'll do one more example, and I think let's look at this one. We have here from 5 to 3, 5 to 2, I'm subtracting 3. And from 2 to -1, again, I'm subtracting 3. Same thing. So I have y is equal to -3x plus or minus some amount. So if I take 2 here, multiply it by -3, that needs to produce 5. So here's the 5. I put 2 in, I get 5 out. So I take 2 times -3, and that gives me, I'm sorry, I need to pause this for a second. Okay, here's a mistake that I just made. I realized if we look at the patterns in all of these other examples, my values here are increasing. My x values are increasing, right? And so when I compare them, I am looking for increases or decreases in y based on an increase of 1 in x. If I look here, I'm not increasing by 1, I'm decreasing by 1. So if I'm decreasing by 1, I can't look for a direct relationship there. I have to think about what's happening. So if I go down 1 here, subtract 1 here, I'm really subtracting 1 here, but this is negative. That direction is negative. So rather than going down 1, let's go up from -2 to -4. Well, how do I get up there? I've added 3. And if I go from there to 0, I add 3 again. And so because this is going down, that negative actually is a positive. It has to counteract the going down. And so we have +3. And so let me cross that out. We have a +3, so I have 2 times 3. And that gives me 6, and somehow from the 2 times 3 I need to get 5. Oh, okay, well, I'm going to have to subtract 1. 2 times 3 is 6. 6 minus 1 gives me 5. So I have +3 minus +3x times, or let me say that one more time, y is equal to 3x minus 1. And so the takeaway from this is it's very important to be aware of what's happening in the x. If the x is increasing, then everything's direct. If x is decreasing, then we have to recognize that it's the opposite way, or go back, work the table of values back up. And I'm going to stop there, and then I will pick up a few more examples in the next video.